Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P08B0, refers to an issue with the neutral position sensor B circuit in a 2022 or newer Honda Civic. Specifically, the code indicates that the output voltage from the neutral position sensor B exceeds a defined threshold, leading the powertrain control module, PCM, to conclude that there's an abnormal situation. The neutral position sensor plays a critical role in informing the vehicle's transmission system, whether the gear is in neutral, thus allowing smooth and accurate gear shifts. It is situated in the transmission area, typically connected with several wires leading back to the PCM. A high voltage output from this sensor can result in transmission performance issues, preventing the vehicle from shifting properly or even starting. To address this problem, a detailed diagnostic procedure must be followed, ensuring the correct identification and rectification of the fault. The error described by DTC P08B0 primarily involves the neutral position sensor B and the powertrain control module, PCM. The neutral position sensor is responsible for detecting whether the transmission is in the neutral position. This is crucial for the proper operation of the vehicle's transmission. When the sensor detects a neutral position, it sends a corresponding voltage signal to the PCM. If this signal exceeds the established safe threshold, the PCM interprets this as a fault and registers the DTC P08B0. The PCM is critical as it receives input from numerous sensors and controls essential functions within the vehicle. It is typically located within the engine compartment or cabin and is connected to various sensors and circuits with wiring harnesses. Ensuring that both the sensor and wiring are in good condition is essential to resolving the issue flagged by this DTC. To address DTC P08B0 effectively, it is important to understand the likely causes. Firstly, a faulty neutral position sensor can lead to erroneous voltage readings as the sensor may not function correctly, therefore sending a higher voltage signal than what is deemed acceptable. Secondly, issues within the wiring, such as open circuits or short circuits, can also create false readings. The integrity of the wiring connecting the sensor to the PCM must be checked, as damaged insulation or breaks in the wire can lead to electrical malfunctions. Lastly, if all other components test as operational, there may be a fault within the PCM itself, resulting in incorrect processing of the signals it receives. Identifying the exact cause is crucial for restoring the vehicle's function. Recognizing the symptoms related to DTC P08B0 can greatly assist in diagnosing the problem efficiently. One primary symptom includes incorrect gear shifting, as the PCM may misinterpret the position of the gear based on faulty signals from the neutral position sensor. This can lead to gears not engaging or disengaging properly, causing a range of operational issues. Another common symptom often observed is difficulty starting the engine. If the PCM believes the transmission is in gear instead of neutral, due to a high voltage signal, it may prevent the engine from starting altogether. Additionally, drivers may notice warning lights illuminated on the dashboard, which could signify a general transmission issue that requires immediate attention. Paying attention to these symptoms allows for quicker diagnosis and repair. The first step in troubleshooting DTC P08B0 involves preparing the vehicle for diagnostic checks. Begin by connecting the vehicle's ignitions to the on position, which provides power to the vehicle's electronic systems, including the PCM and the sensors involved in the system. Next, confirm the reading from the Honda Diagnostic System, HDS, for the neutral position sensor, NSS2. Under normal conditions, the HDS should display a reading of 0 volts, indicating that the sensor is operating correctly. If the reading deviates from this expected value, it indicates that further inspection of the neutral position sensor or associated circuitry is warranted to identify the source of the problem effectively. In the second step of the troubleshooting process for DTC P08B0, further inspection of the neutral position sensor is required. Ensure that the neutral position sensor's 4P connector is disconnected before initiating the tests. With the vehicle still in on mode, measure the voltage output at the connector terminals. Under normal conditions, the output voltage should read approximately 5.0 volts. If the reading is within this range, it suggests that the neutral position sensor itself is likely functioning correctly, indicating that the issue may lie elsewhere in the system. However, if the voltage substantially deviates from this standard, it may indicate a fault with the sensor, necessitating its inspection or replacement. The third troubleshooting step involves inspecting the NSS2 and SG1 circuit. Preparation for this phase necessitates disconnecting both the neutral position sensor's 4P connector and the PCM connector. After ensuring safety and correct disconnection, utilize the HDS to check the SCS line, enabling efficient diagnostics. Once prepared, specific tests must be performed according to the provided inspection table. During the open wire inspection, ensure that less than 1 ohm is measured to verify the integrity of the SG1 wire circuit. This continuity check is crucial as high resistance or discontinuity indicates potential wiring problems, which can lead to the high voltage condition triggering DTC P08B0. For the fourth step in troubleshooting DTC P08B0, it is essential to confirm that the NSS2 wire is not shorted to power. This check requires the vehicle to be in the on mode while the appropriate tests are performed. A successful result in this context would mean that the NSS2 wire shows no signs of shorting, confirming that it maintains its expected signals without introducing any unintended faults. If shorting is detected, it signals a critical issue with the wiring that must be corrected. Following through with the appropriate inspection methods as outlined will lead to a comprehensive analysis of the circuit integrity. Successfully confirming this condition may help isolate the issue to the neutral position sensor or indicate further analysis of the PCM is needed. The final troubleshooting step for diagnosing DTC P08B0 involves inspecting the Powertrain Control Module, PCM. If previous tests have confirmed that the neutral position sensor and its circuit are functioning as expected, the PCM may be the remaining suspect. The PCM acts as the vehicle's brain, processing inputs from different sensors and dictating proper vehicle functions based on those inputs. To conduct this inspection effectively, evaluate the PCM's operations to determine if it is correctly processing the signals. Anomalies or signals that do not match expected values will indicate that the PCM may need repairs or replacement. This step verifies whether the DTC is due to sensor failure or if the root cause is within the PCM. Following the completion of repairs related to DTC P08B0, it is essential to perform a final verification of the repairs made. This involves testing the functionality of the vehicle to ensure that all systems are performing optimally and that the fault has been adequately resolved. After confirming that all repairs are conducted, utilize the diagnostic tool to clear the DTC from the PCM. Once cleared, it is prudent to conduct a retest of the diagnostic system while monitoring to see if the DTC reappears. If the DTC remains absent after the retest, the repairs can be considered successful. This verification ensures that the vehicle is now operating under standard conditions without the previously noted issues. For long-term maintenance and to prevent issues such as DTC P08B0 from reoccurring, regular inspections of the neutral position sensor and associated wiring are recommended. Ensuring that the sensor functions correctly involves checking for proper voltage outputs and watching for any corrosion or damage on the connectors. Regular maintenance of the wiring harness is equally important. Maintaining its integrity helps avoid electrical shorts or open circuits that may eventually lead to faults. Using protective coverings where needed can minimize exposure to environmental damage. Overall, proactive maintenance significantly contributes to vehicle reliability and performance, reducing the likelihood of unplanned repairs in the future. In conclusion, DTC P08B0 indicates a specific issue related to the neutral position sensor B circuit, which can significantly affect vehicle performance, particularly transmission functionality. Identifying and addressing the root cause through a stepwise troubleshooting process allows technicians to systematically eliminate potential issues, from sensor failure to PCM malfunctions. Regular preventive maintenance is key in enhancing vehicle reliability and ensuring such problems are caught early on. By understanding this diagnostic code and employing the detailed troubleshooting steps outlined, individuals can better service Honda Civics, particularly the 2022 and newer models, ensuring a smoother operation and enhanced driving experience. Adopting a proactive approach to maintenance can save vehicle owners both time and cost down the road. Please like and subscribe to the channel. See you next time.